All right, we're going to look at this problem and try to use one of our Pythagorean identities to see if we can simplify it. And so we're going to first multiply. This is what we're given in the problem to do. So we're going to multiply first sine theta times secant theta plus 1. So we will have a distribution here. So we'll just write sine theta times secant theta, and we'll leave it like that for now. And sine theta times 1 will be sine theta. All right, on the denominator, we have conjugates to multiply. So we can use the little shortcut. The outside and inside are going to cancel from FOIL. So we can just do secant squared theta minus 1. And this one is going to give you one of the Pythagorean identities. It is a version of, I'm going to write it here and then I'm going to erase it in case it's in my way. But it is going to be the tan squared theta plus 1 equals secant squared theta. All right? So if we just move the 1 to the other side, then it would be secant squared theta minus 1 would equal this, and that would be tan squared theta. So move the minus 1 over, and you have tan squared theta. So we're going to replace this, and I can leave that there. We'll replace this with tan squared theta, and that is with the Pythagorean identity. So I have sine theta secant theta plus sine theta over tan squared theta. All right, now I am going to go in and I'm going to rewrite this secant theta as its reciprocal cousin, which is 1 over cosine theta, and I'm going to rewrite tan squared theta as sine over cosine with the square. All right, so and sine theta, and this will be 1 over, so we're going to get a complex fraction, cosine theta plus sine theta. It looks even messier, right? And tan squared theta will be sine squared theta over cosine squared theta. Now, we are going to clean up this complex fraction and get rid of this these fractions in the denominator. So let's multiply by the common denominator, which would be cosine squared theta. So I'm going to multiply the whole numerator and denominator by cosine squared theta. So cosine squared theta, and that will take care of this piece. I'll just do it over here too, and here. All right, now let's clean up. It is going to cancel out this. This one will cancel this one piece. That'll cancel this square. All right, and this one is left. Okay, so let's see what we have now. We have cosine theta, sine theta, plus sine theta, cosine squared theta over sine squared theta. Right? Now notice that you have sine in both pieces and also in the denominator. So I'm going to divide out one of the sine thetas. So this one, and one of these. Right? So now, if I break it up, I have cosine theta over sine theta plus cosine squared theta over sine theta. Now let's switch to the other definitions for these. Cosine over sine of theta is cotangent theta, right? And if we only used just a cosine here instead of cosine squared, this would be cosine over sine, would be cotangent theta, but we still have this cosine left, times a cosine of theta. So, pretty tricky. Okay. All right. But I started off and I had to use this, I did the multiplication like they said, but I used this identity, 10 squared plus 1 equals secant squared, and substituted. Then I switched and replaced with cosine for secant. So that was my plan of attack. There might be a different one.